All right, so we are going to cover the volume of pyramids, cones, and spheres, and they're all actually pretty similar to each other, just some small differences. So, starting with the volume of a pyramid, it is your base area times your height times 1/3, or another way to write it would be, so I'm trying to finish coloring, volume equals big B, your base area times height divided by 3. And if you notice with this shape, it doesn't matter if it is a right pyramid or an oblique pyramid. And remember, oblique is just the fancy way of saying that it's kind of slanted. But regardless of whether or not it's oblique or right, it is still going to be the same formula. So looking at this, both of these give the height, so that's the nice thing. It's not slant height. We don't have to do extra work. So to find our base area for this is 9 times 9, which is 81 centimeters squared. And then our height is this value right here. Notice it goes straight from the top of the pyramid all the way to the bottom, and it has that little right angle in there. And that height is 9 centimeters. So when we do our volume formula, base area times height divided by 3, you're just plugging in the numbers you know. So base area we found was 81. The height was 9. And then we have to divide by 3. And so then you pull out your handy dandy calculator if you can't do it in your head. 81 times 9 divided by 3 is 243, and this would be centimeters cubed. Okay. For this one, it's going to be a little bit more complicated because we have to find our base area, and we have a hexagon as our base. So we'll just fill in the height real quick. The height of this pyramid is 10 feet. And to find the area of this hexagon, because remember, that's our base. Let's fix that. Let's make that a little bit closer to what it needs to be. Okay, wow, I just need to retry this. So, to find the base area, we have to find the apothem. So remember, the apothem is smack dab in the middle of that shape, and it goes straight to the middle of the side. So the full length of this side is 12 feet. And remember, we generally are just going to look at this little slice of it. So looking at this slice, and actually I'm just going to draw the one right triangle. To get the big angle for this entire slice, you would do 360 divided by your number of sides. So that's 6 in this case. So that would be 60 degrees. But then, because we're only looking at half of it, we're going to divide that by 2, which would give us 30 degrees. So I know on this little sliver that I'm looking at that that angle at the top is 30 degrees. So then, because the full side length is 12, I know that this little half side of it is 6 feet, and we are solving for the apothem. So this would be tangent, because we have opposite and adjacent. So we have tangent of 30 equals opposite over adjacent. We have to multiply by a to cancel it out on the right. And then we divide by tangent of 30. And then that gives you that a, and 6 divided by tangent of 30 is 10.392. And I'm just going to go out an extra decimal place just in case I need it. So now that I have my apothem, I can find my base area. So let me use a different color. Let's do orange. Remember, base area is your apothem times your perimeter divided by 2. So we would have 10.392 times perimeter. So since this is 12 feet long, I would do 12 times 6 because there's 6 sides. And then we divide by 2. So then 10.392 times 72 divided by 2. Oops, I pushed the wrong button. Hold on. Divide by 2. There it goes. And that gives us a base area of 374.11. And again, this is approximate because I did round some. So if you got slightly different, it's not the end of the world. But since we know our base area is 374.11, now we have all of the information we need. So we're just going to plug it right into the volume formula. Volume equals base area times height divided by 3. Ooh, I did write 3 and then went crazy. So base area is 374.11 and height is 10. And then we divide by 3. So then on my calculator, I'm just going to do times 10 divided by 3. And that gives me a volume of 1,247.04. And this would be in feet cubed, like that. Okay, so this is about the worst it's going to get, because when you have to find your apothem, there's a lot of side work to it, and then you have to plug it in to find your base area, and then you can actually plug it into the volume formula. So just keep in mind what you are solving for and what you need in order to solve. With the volume of cones, it is basically identical to pyramids. It's still base area times height divided by 3, or if you prefer, you can use 1/3 pi r squared h. And again, with this, you can write as bh over 2 like that. Again, whether it is a right cone or an oblique cone, it doesn't matter. It's still going to be the same formula. It doesn't matter if the height goes to the middle or to the center of the circle at the base or not. It just needs to hit the base at a right angle. So we have this beautiful cone, and with this cone, our base area is going to be based off of the circle. So because my radius is 16, I'm going to have pi r squared, which is pi times 16 squared, which would give me 256 pi. And I would leave the base area in terms of pi because we only care about the decimal answer at the very end. So then to find the height, it is this red dotted line in the middle, but you notice we don't have any measurement there. We only have this 34, which is a slant height. But if you notice, we have this right triangle inside of here that has a leg of 16 and a hypotenuse of 34. So we can use the Pythagorean theorem to help us find our height. And so I will actually label it h, and in the Pythagorean theorem, I'm going to put plus h squared. Remember, you can change your variables if you want. So then 16 squared is 256 plus h squared equals 1,156. So then we would subtract the 256, and that gives us h squared equals 900. And then the square root of 900 would be 30. So we found our height is 30. So now that we have our actual height and our base area, we can plug it right into the formula. So volume equals base area times height divided by 3. My base area was 256 pi, and my height was 30. So then 256 times 30 divided by 3 gives you 2,560 pi centimeters cubed, or remember, round it to nearest hundredth, we would multiply this by pi, and that would give us 8,042.477. So since we're going nearest hundredth, we're going to look at this 7. That 7 tells us to round up, so it's going to be 0.48 centimeters cubed. Okay. This next cone, we have the given diameter. So if the diameter is 18, we know our radius is just 9 meters. So to find our base area, it'd be pi r squared, so pi times 9 squared, which would be 81 pi. And then to find our height, it is 8 meters, and they gave it to us, so we don't have to do extra work. So then we're just going to plug it straight into the formula. Base area times height divided by 3. My base area is 81 pi. My height is 8, and we divide by 3. So 81 times 8 divided by 3 is 216 pi, and this is meters cubed. Or we take 216 and we multiply it by pi to get 678.584. So we just be 0.58, because remember, we're looking at the 8, the 4 tells us to keep it. Okay? So, with the next one, we're just going to talk about some of the parts of a sphere, which you might be familiar with some of this. So, a sphere is the locus of points in space that are a fixed distance from a given point, called the center of the sphere. A radius of a sphere connects the center of any sphere to any point on the sphere, and a hemisphere is half of a sphere, and a great circle is what divides a sphere into its two hemispheres. Really, the main part is that you need to know hemisphere, you need to know radius, and you need to know what we mean by center, which I would say most of you probably already are pretty familiar with most of that. So the volume of a sphere is slightly different than the others, but on the test you will be given a formula sheet, so don't feel like you have to memorize these. But it is 4/3 times pi times your radius cubed. And you have to be careful with radius because sometimes, based on the labeling, it'll be hard to tell which one is, if they're talking about radius or diameter. So here is a quick little rule. If the number is in the middle like this is a diameter because it's in the middle, it is applying to the entire line. If it is over to the side like this one, it would just be a radius. And most of the time they do generally just have the one line drawn rather than the entire thing, but just keep in mind if it is slightly to the left and they don't have like an arrow pointing to the entire thing, then it is going to be the radius. So to find the volume of these spheres, this is what I'm talking about with that little line coming down. That 24 inches is the diameter. So then that means my radius would be 12. So then volume for a sphere is volume equals 4 pi r cubed divided by 3. And I realize now that I did not write it like that up here. So if you don't like the 4/3 pi r cubed, you can write it as 4 pi r cubed divided by 3, and that will give you the same result. So, coming back down, oops, go away. Oops, I know. So, we know our radius is 12, so we have volume equals 4 pi 12 cubed divided by 3. So now you're just plugging and chugging. 12 cubed is 1,728. Times 4 is 6,912, divided by 3 is 2,304. And so that would be 2,304 pi inches cubed. Or, as a decimal round to the nearest tenth, we would multiply 2,304 times pi, and that would give us 7,238, 238.2. And the decimal, if you have your calculator, is 0.22, but since we're rounding to the 10th, that 2 tells us to stay where we're at and just keep the 2. Almost forgot my label too. Okay. For this next one, again, they are using the arrow to say that that entire line is the diameter. So that means my radius is 25 centimeters. So plugging into the formula, 4 pi r cubed divided by 3, we would plug the 25 in where the r is, so 25 cubed divided by 3. So then when you multiply it all out, divide by 3, that would give you a volume of 20,833.3 pi. And even though it's a decimal, you can still put the pi after there. Or, if we multiplied by the pi, that would give us 65,449.8 centimeters cubed. Okay. For these last two, it's just a rectangular pyramid. So if you want, you can draw yourself a picture. For some people, it might just help have a visual, and this is not going to be a pretty one, but we'll work with it. So, ooh, sorry. So with this rectangular pyramid, we have a length of 25 centimeters, a width of 17 centimeters, and a height, which remember comes from the top all the way down to the bottom and has a little right angle. The height is 21 centimeters. So since this is a pyramid, we're going to have volume equals your base area times height divided by 3. So in this case, base area would be 25 times 17, and then my height is 21, so we multiply by 21, all divided by 3. And 25 times 17 times 21 divided by 3 gives you a volume of 2,975 centimeters cubed. So a lot of this, just plug it and chug it and working your way over there. For this last one, it is a cone with a diameter of 22 centimeters and a height of 30. So again, if you need a circle to kind of help, or a picture to help you see what you're doing, that's totally fine. But for this cone, we have a height of 30 centimeters, and we have a diameter of 22. So, since I have all that, my diameter being 22 means my radius is 11 centimeters. So then we plug it into the formula. Volume is your base area times height divided by 3. In this case, our base area is pi r squared because it's a circle. So it'll be pi 11 squared times height, which is 30, all divided by 3. And then 11 squared times 30 divided by 3 gives you a volume of 1,210 pi centimeters cubed, or take that, multiply by pi, and that gives you 3,801.3. And this is, again, centimeters cubed. So a lot of this is just figuring out what values you need and plugging them into the formula. So if you have questions, feel free to comment below or email me or however you want to get a hold of me.